Multi-angle valve jobs are a critical process in engine performance tuning. By machining the valve seat at several precise angles, airflow into and out of the combustion chamber is significantly improved. However, the effectiveness of this technique relies heavily on blending the transitions between each angle smoothly. Proper blending eliminates sharp edges that can disrupt airflow, ensuring a seamless path for the air-fuel mixture. This attention to detail ultimately enhances engine efficiency and power output. The machined valve job process is a critical step in engine performance and longevity. During this procedure, specialized equipment is used to precisely cut the valve seat, creating multiple distinct angles. These angles help to improve airflow and ensure a tight seal between the valve and the seat. By optimizing the contact surfaces, the process enhances combustion efficiency and reduces the risk of leaks. The result is a more reliable and efficient engine operation. Hand porting the bowl area involves carefully refining the contours and surfaces inside the cylinder head to optimize airflow. This process allows for greater precision than machine work alone, enabling the technician to address subtle imperfections and achieve a more consistent finish. Ensuring a smooth transition between the machined and ported surfaces is crucial, as any abrupt changes or rough edges can disrupt the flow of air and fuel. Such disruptions can lead to turbulence, reducing engine efficiency and performance. By blending these areas seamlessly, the overall airflow is improved, supporting better combustion and power output. Identifying the boundary between machined angles and hand-ported bowls is a crucial step before blending. Typically, the machined surfaces display uniform tool marks and sharp transitions, while hand-ported areas appear smoother and more irregular. Careful inspection under good lighting can help reveal these differences in texture and finish. Using layout dye or a contrasting marker can further highlight the edge where the two surfaces meet. Recognizing this boundary ensures that blending is precise, maintaining both performance and consistency in the finished component. To achieve a smooth blend using burrs, start by selecting the appropriate burr shape for your project, such as a flame or tapered burr for tight spaces. Attach the burr securely to your rotary tool, ensuring it is compatible with the material you're working on. Begin blending with gentle, sweeping motions, moving the tool in overlapping circles or back and forth strokes to avoid creating harsh lines. Maintain a consistent speed and light pressure, allowing the burr to do the work without forcing it. Periodically check your progress and adjust your technique as needed for a seamless, professional finish. When blending during a valve job, it's crucial to preserve the original angles and surfaces to maintain proper sealing and performance. Use gentle, controlled motions and avoid aggressive grinding, as removing too much material can compromise the valve seat's integrity. Focus on smoothing transitions rather than reshaping the seat. Regularly check your progress with visual inspections and feeler gauges to ensure you're not exceeding material limits. Taking a careful, measured approach helps ensure the valve job remains precise and reliable. Visual cues play a crucial role in identifying any irregularities between the machined seat and the ported bowl. By closely observing the surface, technicians can spot inconsistencies that may affect airflow. Tactile feedback, such as running a finger along the transition, helps confirm a seamless blend. This combination of sight and touch ensures the transition is smooth and even, optimizing performance and preventing unwanted turbulence. During the blending process, several common mistakes can affect the final outcome. Overfilling the blender may lead to uneven mixing or spills, so it's important to follow the recommended capacity. Using the wrong speed setting can result in either underblended or overly processed ingredients. If you notice lumps or unblended pieces, stop and scrape down the sides before continuing. Additionally, always ensure the lid is securely in place to prevent leaks or accidents. Addressing these issues promptly helps achieve a smooth and consistent blend. Final inspection is crucial to ensure a seamless transition between the newly machined surfaces and the original areas. Technicians often use bright lighting and magnification to closely examine the blend, checking for any visible lines, steps, or inconsistencies. Special attention is given to the valve job area, where a smooth, uniform finish is essential for optimal sealing and performance. Any rough spots or irregularities detected during this inspection may require additional blending or polishing. This meticulous process helps guarantee both the reliability and efficiency of the finished component. A well-blended valve job and a ported bowl offer significant advantages for engine performance and durability. By smoothing the transition between the valve seat and the port, airflow is improved, resulting in more efficient combustion and increased power output. Enhanced airflow also helps the engine run cooler and more consistently, reducing the risk of hot spots and premature wear. Over time, these modifications contribute to better fuel efficiency and extended engine life, making them valuable upgrades for both performance enthusiasts and everyday drivers.